In 1945, the science fiction writer Arthur C. Clarke first explored the idea that satellites could be used for broadcasting. Using Kepler's laws of planetary motion and Newtonian mechanics, Clarke's paper gave the exact conditions for putting a satellite into geostationary orbit. Today, there are hundreds of such satellites orbiting the Earth, and SES Global's operating companies and partner companies around the world operate over 40 of them. They provide audiovisual entertainment and information, broadband data and telecommunications services to an area that is home to 95% of the world's population. So how does the geostationary orbit work? A body of any sort orbiting the Earth, one such as our Moon, for example, stays in permanent orbit when the gravitational forces attracting it to the planet are balanced by the centrifugal forces generated by its speed of travel around the Earth that tend to send it flying outwards. The speed at which a satellite needs to travel for these forces to be in balance depends on its distance from the planet. Near the Earth, where the gravitational attraction is greater, its speed would have to be very high, and anyone wanting to receive signals from the satellite might only be able to do so for a couple of minutes at a time. In the same orbit as our Moon, they'd be able to see the satellite for about 10 hours a day, but in either case they would need a reception dish which constantly tracked the moving satellite across the sky. But at 36,000 kilometers above the equator, about 1/10 of the way to the Moon, and with a speed of 13,000 kilometers an hour, a satellite will stay in orbit at the same point or orbital position over the Earth as it rotates. And that means that viewers on the ground can pick up signals 24 hours a day, 365 days a year, from a fixed reception dish. An orbital position is actually a box, about 150 kilometers each side, in which the satellites are parked. In addition to the major forces that keep the satellites in orbit, they're subject to other forces too. They're affected by the gravitational pull of the Moon and the planets, and by distortions in the Earth's gravitational field. Mountain ranges, such as the Himalayas, can pull them off course. On the ground, at control centers located around the world, huge parabolic antennae track each spacecraft. The control centers receive a constant flow of information from each satellite, telling them their precise locations at all times and the exact status of the onboard systems, which are exposed to the harsh environment of space. Highly skilled engineers control their fleets in space, monitoring flight dynamics and carrying out precision maneuvers. By remote control, the onboard thrusters are fired from time to time to ensure that the satellites remain in their geostationary positions, thus maintaining the highest quality of program transmission 24 hours a day, 365 days a year. Satellite operations become even more complex and challenging where several satellites are co-located at the same orbital position. This is the case in Europe, for instance, at SES Astra's orbital positions of 19.2 and 28.2 degrees east. The co-located satellites are constantly monitored and controlled to synchronize their flight from the Astra Satellite Control Center at Château de Betzdorf in Luxembourg. Co-locating satellites means that Astra can supply many more channels and services from an orbital position than could ever be carried on a single satellite. It also means that the system has built-in backup and reserve capacity should one satellite or part of a satellite fail. The lifetime of a satellite in space is mainly determined by the amount of fuel it carries for these station-keeping maneuvers. And the SES Global companies around the world have an outstanding track record of successful satellite management. Through careful planning and efficient use of that fuel, the engineers maximize the lifetime of our satellites, while at the same time guaranteeing an unrivaled 99.99% network availability for our clients.
Drive straight 200 meters. At the next crossroads, turn
Bueno, nos odiamos esta noche. ¿Aló? ¿Aló? Dura ancora così, pallone morbido, si dalla parte opposta.
the Sentinels, Galileo, Meteosat. These are Europe's existing and future satellite systems, our riches in space. Without them, our lives would be very different, our vision of the world much diminished. They are far distant, but bring us closer together. Every day we ask ourselves, what's tomorrow's weather? Day and night, meteorological satellites send us a complete atmospheric picture of the Earth. A depression or anticyclone becomes immediately visible as it forms and develops, something which is impossible to see from a single location on Earth. Satellites are part of our everyday lives. Today, the European GSM mobile telephone standard allows more than 2 billion people around the world to communicate. In the future, integration with satellite communication applications will revolutionize the way we use our mobiles and enable applications such as television by satellite to handsets. GNSS, global navigation satellite systems, have become indispensable for diverse fields, ranging from transportation to banking. The future European Galileo satellite positioning system will create major opportunities for the European economy by introducing new services for citizens. GNSS also provides safety and precision in flight. Never have air travelers been so safe. Emergency services guided by satellites save hundreds of lives every year. Satellites also help our armed forces on their peacekeeping and humanitarian missions. Climate change is a reality, and Europe leads the world in combating it. The European Initiative on Global Monitoring for Environment and Security will watch over the health and safety of our planet day and night. We will be rapidly informed of changes such as rises in the surface temperature of land and sea. We will be able to identify a region at risk and intervene rapidly to save lives. As the Earth's guardian angels, Earth observation satellites monitor the environmental impact of human activity: pollution, deforestation, desertification. They allow assessment of the state of our natural resources. Never before has information on our environment been so timely and reliable. For many populations on Earth, a lost harvest can be dramatic. From space, solutions emerge for problems as serious as poverty, malnutrition, and famine. Satellites are precious allies in humanitarian aid. As a driver of research and innovation, European space helps to better understand the universe. It also has strategic importance. Space industry maintains Europe's industrial capacity at a highly competitive level. It creates new jobs, new services. Europe occupies a leading position in the space sector. Its highly competitive space industry successfully exploits commercial opportunities created by space applications. Its satellites are a guarantee of political and industrial autonomy, of Europe's independence and prosperity. Today, our planet, the Blue Planet, is a huge village where ideas can be exchanged and knowledge flourish without limits. The Europe of space is a reality.